Okay, hello class. Welcome to lesson one of functions. So this would actually be on day two, but day one, we're just kind of doing some intro stuff. But we're actually going to start talking about what is a function today. Um, so here's a warm-up question. It kind of goes from the circle that we did on day one. But if we consider the equation y equals the square root of x, notice it's not plus minus, it's just the positive square root of x. What kind of numbers can we input into the equation, and what would the outputs be? And so this is a similar idea. What numbers are you allowed to sub in? We got into this a little bit with the circle, but what numbers would you be allowed to sub in which would work? And then what would the outputs be? This is a function that we're going to explore in this first unit, but I just want to ask the question in this way of inputs and outputs. So I want you to think about that. The goal for today is we're learning to use the characteristics of functions and function notation to describe functions and determine information. That's going to be a bigger goal that we're not going to tackle all just this class. This class is really just this first part, explain the meaning of the term function, so like the definition, and differentiate between a function and a non-function. So first off, what is a function? So a function is a relationship between two variables, so very similar to what we've seen as a linear relationship or a quadratic relationship, but it's such that every value of the independent variable, so every x value, you only get one output. So you notice in the circle, we actually, like, if you subbed in an x value, you could get two outputs, but for a function, if you sub in like any value, you only get one value out. Another way of saying it is for every x value, there's only one y value. If we talk about x being the independent variable and y being the dependent. How can we represent functions? There's four ways that we're going to look at in this course. A mapping diagram, a table of values, which we looked at a little bit in the first lesson, a graph, and an equation. So first off, a mapping diagram. So an example of a function would look like this. So notice if you, and it just tells you like the first circle is your x's and then lead to a y value. And so these are the only possible x values. -1 would give you 5, 1 would give you 5. But notice every time you sub in an x value, every time you look at an x value, you have a direct place to go for the y value. A non-example of a mapping diagram would look like this. So the arrows aren't here, but it's clearly saying which is the x, and the output's the y. -1 points to actually two spots, and that can't actually happen for a function. 1 points to 1 and 2, and that can't happen. But over here, notice that you can get y value of 5. We don't really care about that because like it's just two different x values get you the same y. And that's where the struggle becomes, and so that's where it's like kind of helpful to think about different ways to think about what a function is. But it's really just if you put something in, you can only get one value out, and you need to know what that value is. I always think of a pop machine. If you press a button, the machine has got to give you one output. And really that's why they're important, is because technology can't really make decisions. Like you as the user just want to have one button to press, and you want to know what the output's going to be. A table of values would look like this. Regular table of values, you got x values here. A non-example, you might have the same x value show up twice to two different values. So 0.3, 0.4, that makes it not a function because there's the same input twice for a different output. In a graph, like you could look at something like this. Notice that if you go to x, you know what the output is for y. So if you go to 1, you got 0. If you go to 0, you got 0. If you go to 5, you got 0. For a non-example, it would be like this. It's kind of a parabola turned on its side. If you sub in 4, you get 2, and that's not, you get 2 or -2, and so you don't really know what the answer is, and so that makes it not a function. Vertical line test. Vertical line test, what it's helpful for is, like if you run a vertical line, you can watch the line go, and it hits the function, or it hits the relationship twice, for the same x value, then it makes it not a function. So the vertical line test, that's not the definition of the function, but it helps kind of explain the definition. For every x value, which is represented by the vertical line, you can only get one y value. And so notice that on the first one it works, you only get one y value, but on the second one you've got two y values, and so it doesn't work. The last one in an equation, you can see y equals 3x plus 5. You can clearly see if you sub in an x value, you can get one y value. But the circle, if you sub in an x value, notice that if you try to get a y value out of it, you're going to have to do that plus minus square root. And so that's how you rearrange it. Subtract x squared on both sides and square root. You can see the plus minus gives two values for every one x value. So just this is a quick recap. So notice that this one is the function. This guy is the function of the equations. This guy is the function. And it's this guy is the function. So briefly, why is our functions important? Big idea for the course is that like we can relate one expression to another, one like it. So we can relate, and really kind of, if we can do it to one, we can do it to others. Functions allow us to generalize things. They allow us to work in general terms, like just to talk about, okay, what's happening to that function, rather than to what's happening to the line or the quadratic. We can really talk about more specifics. But the best example I can think of is really when you're talking about a computer. You only really want to press one button and get an output out, and so there has to be an output.